Okay, so we've done some acid and alkalis in previous years within school, and we know already that this should be just general revision, really. But we know that if we start going from a pH scale of 1 to 14 in its usual sense, we know that we start to have acids and alkalis on one end or the other of the spectrum. And we know that generally our acids tend to occur are below pH 7, especially. So they would be towards the left hand side here with 7 in the middle. We then know that our alkalides would be higher than pH 7 in this region of the kind of scale. And we would have common acids that we know of. So common ones in the lab would be hydrochloric acid, sulfuric acid, H2SO4. We might have nitric acid, HNO3. A slightly weaker acid, so we'll look at something such as ethanoic acid, so CH3COOH, acetic acid in old money. Going to alkalis, something such as ammonia, NH3, which is what's regarded as a weaker alkali. Sodium hydroxide, the kind of group 1 metal hydroxides, sodium hydroxide, lithium hydroxide, etc. And they are all very common laboratory reagents that you've probably used and used to prepare salts as you've gone through school. And when we do those, we know that we can use universal indicator to indicate to us whether or not we've got an acid or an alkali, or whether or not we've got something which is of neutral pH, what's regarded as pH 7. And we know that anything, as we say, below pH 7 is regarded as acidic, and anything higher than pH 7 is regarded as alkaline. But you may also remember various phrases such as strong and weak, whereby strong acids would typically have pHs of around 1 to 3, whereas weaker acids would have pHs, say, between 4 and 6. And then likewise, you'd have your weaker alkalis here between, say, 8 and 11, 10, 11. And then again, at the far end of the spectrum, you'd have your strong alkalis. And in a later clip, we'll look in more detail at what defines, primarily with acids, but what defines whether or not something is a strong or a weak acid and why we get that differentiation. And a similar differentiation does occur in an alkaline situation, but we'll look for purposes of GCSE at the acidic versions. But before we go into the next clip, which starts to explain why things are acidic and what makes something acidic, what we can see from these acids that we have on the left-hand side is that in each case we have a very common situation, and that each of these contains a hydrogen. The hydrogen ethanoic acid is actually that one, which is the important one, but they all contain this hydrogen ion, as it is, and it's a H plus ion, and that's what we're going to look at in a subsequent clip. But basically this H plus ion is the important section that we're going to look at when we discuss an acid and how acids then react subsequently with alkalis.